Hello everyone, welcome to another video in my channel. In this video, I will be solving the A part of the 10th theory question of this year's NECO Further Mathematics exam. The question says, a sequence of numbers u1, u2, u3 up to infinity satisfies the relation 3k minus 2 in brackets times uk plus 1, k plus 1 is subscript, is equal to 3k plus 1 in brackets times u subscript k for all positive integers k. If u1 is equal to 1, find I, u1 and u4, I, and expression for uk in terms of k, I, the sum of the first k terms of the sequence, and iv, the value of uk plus 1 plus uk plus 2 when k is equal to 0. This is an interesting question under sequences. We are first of all told to find u3 and u4. u3 and u4 are like the third and fourth terms of the sequence. Let us remember that we are told that k is greater or equal to 1. That is, k is a member of the set of positive integers. Then we are also told that u1, that's the first term, is equal to 1. Then we are given an equation. The equation is 3k minus 2 times uk plus 1 is equal to 3k plus 1 times uk. Now, let me divide both sides by 3k minus 2. So this will cancel this term. Then we now have uk plus 1 is equal to 3k plus 1 all over 3k minus 2 times uk. When k is equal to 1, let us find the value of u2. That becomes u1 plus 1, which is u2, equals to, I'm going to put 1 wherever I see k in this equation. That becomes 3 times 1 plus 1 times u1, that is uk, where k is 1, u1 is 1, all over 3 times 1 minus 2. Now, 3 times 1 is 3, plus 1 is 4. Then 3 times 1 is 3, minus 2 is 1. Therefore, our u2 is equal to 4. What about when k is equal to 2? I'm going to do the same thing I did in the first case. So u2 plus 1 will now give me u3. That becomes the third term. And it gives us 3 times 2 plus 1 over 3 times 2 minus 2. Let's remember that this is uk, that is u2 now, and u2 is 4, giving us 3 times 2 is 6, 6 plus 1 is 7, 7 times 4 here. 3 times 2 is 6, minus 2 is another 4. This and this will cancel. Therefore, u3 is equal to 7. Now, for u4, that is when k is equal to 3, u3 plus 1, which is u4, will now be 3 times 3 plus 1 all over 3 times 3 minus 2. Let's remember this is uk here, and uk is when k is equal to 3, and this is 7 here. I'm going to put this 7 here, equals to 3 times 3 is 9, plus 1 is 10. 10 times 7 over 3 times 3 is 9, minus 2 is 7. So I have this. So u4 is equal to 7. Our u3, as we are asked to find, is 7, and our u4 is 10. 10, please, not 7. Let's now solve the second part of A. Second part says that we should find an expression for uk in terms of k. Let's remember that this is a sequence where u1 is equal to 1, u2 we calculated as 4, u3 we calculated as 7, and then u4 is 10. We are required to find the general formula for the sequence. The sequence is 1, 4, 7, 10 down to infinity. First, let us find what is called the common difference. The common difference is the second term minus the first term, or third term minus second term, or fourth term minus the third term. And we can see that the difference is 3. So how am I going to apply that difference or common difference in finding the general formula for this sequence? I'll do this. I'll write 1 plus 3. To make this one 1, I have to add 0 here, or multiply this by 0. So 3 times 0 is 0, plus 1 is 1. The same thing here, 1 plus 3. This time around, I'll put 1 here. 3 times 1 is 3, plus 1 is 4. The same thing here, 3 times 2. 3 times 2 is 6, plus 1 is 7. And 1 plus 3 times 3. Now, UK, which is the general formula for this sequence, will now become, these 1 are constant, so I'll write 1, plus the 3 here also are constant, I'll write 3. Then the only term varying is the term in the brackets. Now, because they are varying, I'll write K. Because I started with 0, the first term here is 0. And the second term is 1 minus the number of term here. So I'm going to write minus 1 here. And then open this bracket. That gives me 1 plus 3K minus 3. So UK will now be 3K minus 3 plus 1 will give me minus 2. This is now the general term for the sequence. There's another way I can do this. Let us remember that the nth term of a sequence is UN, particularly arithmetic progression. Since this is an arithmetic progression, how do we know that? We have common difference and not common ratio. Now, so the nth term of an arithmetic progression is UN is equal to A plus N minus 1D, where A is the first term. The first term here is 1, plus N can now be substituted with K minus 1. D is the common difference. We calculated the common difference to be 3. So this is now UK. Opening this bracket, we're going to get 3K minus 2 as we did in this case. Now in the third part, we are asked to calculate or to find the sum of the first K terms of the sequence. Simply, all we are required to do is to find a formula that we can use to sum up all the terms. Let's remember that Sn is n over 2, 2a plus n minus 1d. We are going to use this one to find it. It is the same thing as summation n equals to 1 of k, up to k rather, of 3n minus 2. So these two equations or these two expressions are the same or equivalent, whichever one is applicable. Well, I'm going to use this one to find the third part, that is the sum of the first k terms of the sequence. Simply by substituting the value of k for n, that becomes sk is equal to k here over 2, and our a is 1. Remember that u1, that's the first term, is 1. So 2 times 1 plus k minus 1 times d, which is 3. And then simplify. K over 2 times 2 plus 3k minus 3 will give us that. So k over 2 times 2 minus 3 will give us minus 1. So we have 3k minus 1. This is now the sum of terms of that sequence. Lastly, we are required to find the value of UK plus 1 plus UK plus 2 when k is 0. Now, UK when k is 0 will now give us U0 equals to, I'm going to use 3 times 0 minus 2, and that becomes minus 2. And so UK plus 1 when k is 0 will now give us U1, and U1 is 1. Now UK plus 2 when k is 0 is U2. Our U2 is calculated as 4. So I'll put 4 here. So let's sum them up. So UK plus UK plus 1 plus UK plus 2 will now give us minus 2 plus 1 plus 4. And when we add them together, we are going to get 5 minus 2, which is 3. So this is now the answer. Please like this video if you find it interesting. Subscribe to my channel if you haven't done so. And also share this video to your loved ones, because sharing is love and love doesn't cost a thing. If you haven't subscribed to this channel, I would like you to do so. Thanks for watching and see you in another video. Bye.